Okay, so here's a quick square root trick that you must know, okay? A very quick square root trick that you must definitely know, okay? So, I'm pretty sure that some of you guys here, who is, a math enthusiast like me, knows this trick when taking a square root of a absolutely large number. Okay, so let's have an example over here. So let's say we are asked to find the square root of 4 raised to the power of 4. Now you might be asking, hey Theoxis, how do I get this? How do I get this? 4 raised to the power of 4. 4 raised to the power of 4. How do I get 4 raised to the power of 4? Should I supposed to expand this first and go 4 times 4 times 4 times 4? No, you don't need to do that, alright? You don't need to do that. Because, okay, let's have an example over here. Let's take it from the square root of 4 squared. 16, right? Square root of 16 is 4. Well, technically, square root, just cancel this and it becomes 4, right? So let's take this base. Let's base this from this, 4. Okay? You with me? Alright. So that means the square root of 4 raised to the power of 4 is also equals to 4 times 4. Why? Why am I saying this? It's because it's true in mathematics that the square root of 4 raised to the power of an exponent can be a product of this and the previous base, the previous base. Alright? We can have this. Okay, let's say square root of a raised to the power of b. We can equal that to a base. A times a base. So what's our base over here? Of course, 4. 4 squared. Our base is the square root of 4 squared. Or our base is equals to the square root of a squared, which is a. Alright? That's our base. That is our base. Our base is simply a itself, or the square root of a squared. We can just use that principle to multiply a with the base. Now, what am I talking about here? The a. What? Okay, let's have a clear, much clearer explanation here. So a, right? It just came from here. You just take this a, put it over here, and multiply it by the previous base, which is the square root of a squared. It's that simple. That is the trick. So this is equals to a times the previous base, the base. So now you know the base. Okay, let's write it on top of our board so you guys won't forget. Because I really want you guys to apply this trick. Okay, so our base is always to the square root of a squared, which is equals to a. Alright? Can you see the pattern over here? Okay, for example, let's have another example. Square root of 18 raised to the power of 6. Alright, how do we do this? So, our base, we multiply it from the base. Now here's what gets trickier. It's 18 raised to the power of 6. So, we go all the way back to the square root of 18 squared. So the square root of 18 squared is equals to 18. Alright? So the square, and then the square root of 18 raised to the power of 4 is equals to 18 multiplied by 18, or 18 squared. Do you see the pattern here now? 18 raised to the power of 4 is equals to 18 squared. So simply multiply 18 and 18. So what's 18 squared? Okay, let's multiply it. Which is I am shit in multiplication. So what's 8 times 8? I fucking forgot basic mathematics. Let's do it. 8, 60, 32, 40, 48, 56, 64, 64. Okay, let's say, okay, 64. So 8, 9, 10, 11, 12, 13, 14. 144. 18 times 8 is 144. Okay, 8, 9, 10, 11, 12. Okay, just to make sure. Sorry. Okay, of course. 81. Or 18. 18. Okay, let's do it. 4, 12. 1 plus 1, 2 plus 1, 3. 324. 18 squared is 324. 18 squared is 324. Okay? Can you still see the board over here? 18 squared is equals to 324. Now what do we do now, Phioxus? What do we do by this fact? And how are we going to solve the square root of 18 raised to the power of 6? Simple. Multiply 324 times the base, which is still 18. You still multiply it. So this is also equals to 18 cubed. Wait, no. 18 times 18 times 18. Yeah, it's 18 cubed, which is equals to 18 cubed. Do you see the pattern here now? To solve this, you have to do this. Also, I just want to remind everyone that this trick only applies if the exponent is even. If it's not, well, usually it involves square roots of 2 beside it. The result often involves square root of 2 beside it. But we will get to that point later on. We will get to that type of equation later on. So I want you guys to, if you guys want to learn more about this trick, these tricks in square roots, then you have to watch this full video, of course. Because of course I'm explaining it, right? Okay, let's do it. So now you see the pattern over here. So we define a here multiplied by our base, which is a over here. With our base is basically square root of a squared. So we know that, right? So what's a actually? How do we define a in this equation? A is the previous result from this specifically. Let's say a raised to the power of 6. So of course, a is equals to the square root of a raised to the power of 4. This is a sequence of exponents of let's say numbers that is raised to the power of an even number. 2, 4, 6. 2, 4, 6, 8. 10. Those are even numbers. 2, 4, 6, 8, 10. Okay? So now you see the pattern. So that's one of the most easiest ways to get the square root of these type of problems. Problem solved. Alright, so let's have another example over here. Let's have another example over here. Let's have another example, alright? Alright, square root of 24 raised to the power of 12. Raised to the power of 12. How do we do this? Now this is where our trick gets much more difficult. Because in order to get this, we must multiply the square root of 24 raised to the power of 10 times 24. And this is where things get much more difficult because we need to progress this one. Okay, so let's progress this one. Okay, square root of 24 squared is equals to 24. Alright? Square root of 24 raised to the power of 4 is equals to 24 squared. Okay? Which is 24 times 24. Fuck, why did I put x on it? This is not algebra. 24 multiplied by 24. So basically 4 times 4 is 16. 4, 8, 9. 4, 8, 2, 4, 48. So we have 6, 17, 5. So 576. So 576. Okay. Now it progresses much worse. So we got 576. Oh, by the way, I'm not using a calculator, but we can verify this using a calculator. I have a calculator, scientific calculator here right now, and we're only going to use this through verification. So we're going to multiply here. Every computation here is manual, and this scientific calculator is only a verification. So let's see here. So 576. All right. Square root of 24 raised to the power of 6 is equals to 24 squared multiplied by 24 again. So that's 24 cubed now, right? That's 24 cubed. Okay, so let's do it. 576 multiplied by 24. Okay, so what's 6 times 4? Yes, that's correct. It's 24. 7 times 4, that's 7. 28. And then 28 plus 2, that's 30. 5 times 4 is 20, so that's 23 plus 23. There we go. Okay, 6, 12, okay. 12, okay. 7, 14, 15. 5 times 10. 5 times 2 is 10. Plus 1, which is 11. Okay. 4, 2, 7, 3, 1. 1, 3, 7, 2, 4. It gets progressively worse. It gets progressively worse. I know, but this is another cool method, trick. If the powers are even, and this can still be applied. This trick can still be an optional thing to do if you don't know other methods. If you don't know any methods to make your computation much easier, then this trick is applicable. Alright? It may waste time a bit if the base itself is absolutely large, then you're cooked, probably. So anyways, 13724. Okay, let's now erase it since we have stored our answer. 13724. Okay. Let's just verify to see if it's true. 24 squared multiplied by 24. Okay, fuck. What? 24 squared times 24. 13824. Oh no. Okay, we kind of messed up that one. Okay, we messed up. Okay. Sorry about that. We messed up. Okay. 13824. All right. Now square root of 24 raised to the power of 8. Now what do we do with this one? Okay, 24 raised to the power of 8 is equals to 24 cubes multiplied by 24. Alright. Because this is 24 squared times 24. That's equals to 24 cubed. So let's verify that again if that's true. Okay. So 24 cubed times 24 is equals, of course, to 24 raised to the power of 24. Anyways. Now. Is equals to 24 raised to the power of 4. Now what's our raised to the power of 4 over here? Now it's 13824. So it's 13824 multiplied by 24. Okay, now this is torture, right? Okay, 16, 4, 8, 9. Okay, 8, 16, 24, 32. 4, 8, 12. 13, 14, 15. 4, 5. Okay, there we go. We have it. So we got 4, 8. 2, 4. 8, 16. Okay. 3, 6, 7. Okay. 2, 6, 17. 3, 4, 5, 6. Wait, no. 3, 5, 6, 7. Okay, 7. Okay. 11. Okay, 7, 11, the shop. 6 plus 7, so 13. 3. 3, 3, 1, 7, 7, 6. Okay, let's confirm if this is true. 331776. Alright, we good. Okay. Now it gets progressively much worse because it's going to be a lot of pain. Alright? Equals to 24 cubed. Okay, now this is 331,776. We're almost there. We're almost there. Now here we have it. Here we have it. Okay, square root of 24 raised to the power of 10 is equals to 331,776 multiplied by 24. But I'm not going to waste time anymore. We are going to calculate this immediately. Okay, using the scientific calculator, we're going to calculate this already because we're just wasting time at this point. But you know, yeah. So 796. So now we got, okay, let's erase all of this now. So 796 2624 multiplied by 24 is equals to the square root of 24 raised to the power of 12. Can't you fucking believe that? Wait, is it really done? I could be wrong in this one. Let's just find out, okay? No, this is correct. So the square root of... Okay, let's just... Okay, we're good. Okay, now we will multiply this by 24. Let's see. Let's just find out. 7962624 multiplied by 24. Okay, let's actually manually compute this now because we're literally just close to that. For the suspense, for the tension, for the suspense. But if you have a calculator with you, then you can just go ahead and skip this part. Okay. 60. 9. So 191102976. Wait, is this millions? Wait, is this a fucking million? Oh my goodness, I think it is. 19 million! Goodness gracious! Okay. Goodness. Oh my goodness, okay, so the square root of 24 raised to the power of 10 is 24. Jesus. Okay. Okay. Well, we were actually going for the full damn number value for this. So therefore, the square root of 24 raised to the power of 12 is equals to 191102976. Let's find out. Let's find out if I'm correct. Okay, 24 raised to the power of 12. We got, goodness gracious, it is true. Now, you may be asking, Phioxis, why did you even waste your time trying to get the actual value for the square root of this, when you can just use the laws of exponents? I don't memorize the laws of exponents, so we have another method, which is this. This also fucking works. So let's go back again, one by one. So 24 squared is equals to 24. Okay. So square root of 24 raised to the power of 4 is equals to 24 squared. Correct? Okay. Now square root of 24 raised to the power of 6 is equals to 24 cubed. Is it 24 cubed? Because it's 24 squared now, multiplied by 24, so it's 24 cubed. 24 cubed, okay. So square root of 24 raised to the power of 8 is equals to 24 raised to the power of 4. Alright? Now do you see the pattern over here? 24 squared, 24, 24 squared, 24 cubed, 24 raised to the power of 4, as long as the exponents are even. So therefore, the square root of 24 raised to the power of 10 is equals to 24 raised to the power of 5. Now, do you see the pattern now? 24 raised to the power of 5. So, therefore, the square root of 24 raised to the power of 12, or 24 raised to the power of 6. See? 24 raised to the power of 6. What's our 24 raised to the power of 6? It's the same thing. See? I don't think you need the laws of exponents for this particular type of problem if you know the pattern for the rest of the square roots. Okay, just simply memorize this. Simply know this. Square root of 24 squared is 24. Square root of 24 raised to the power of 4 is the same as saying 24 squared. It's division. It's division. It still follows the laws of exponents for a bit. 24 squared, and then we take the square root of that. It's still 24. 24 raised to the power of 4, that's 24 squared. We're just reducing them. Because, okay, let's see here. Reduce 4 by 2. Divide 4 by 2. That's 2. Okay, 6 divided by 2, that's 3, because 2, 4, 6, 3. Divide 8 divided by 2, that's 4, because 4 times 2 is 8. 10 divided by 2, that's 5, because 5 times 2 is 10. See? That's the pattern. That's the pattern. That's all you need to know. If you don't want, if the full value is not needed and you just need to simplify it, then just divide this by 2 and you're good. 24 raised to the power of 6. 24 raised to the power of 6. That's all you needed to know. Unless the person asked you to reduce it even further, then that's like 2 square root of 6 raised to the power of 4, I think. Was it raised to the power of 4? No. Still. Okay, never mind. Let's just move on. Unless if you want to reduce it, then we can just simply express 24 raised to the power of 6 as equals to 2 square root of 6 squared raised to the power of 6. Really just the same thing. It's basic. This is basic. If it's asked to simplify this only, and you don't need the actual full value for this one, then you can write this, because this is just a division. This is actually a division in exponents, and I think there's a law stating this like division of the division of the exponent. If the exponent is even, then that's true. All right. What's our time? Okay, 29 minutes into the video. Okay, we're almost at 30 minutes. Okay, now we're done with the even exponents. Now let's talk about odd numbers, odd exponents. Okay. Now this is a bit more tricky. Because, okay, let's 15 raised to the power of 4. Okay, so 4 raised to the power of 5. 1024, so squared answer is 32, so 32 squared. Okay, square root of 42, that's 4 squared. Okay, so odds. Okay, how do we define odds? Okay, so odd exponents. Hold on a second. My mind is processing. So, okay, let's say 2 raised to the power of cubed, 3 cubed. 2 raised to the power of 3, so that's 2 times 2 times 2. So that's square root. That's basically saying 2 cubed plus 2. No. The fuck? What? That's Pythagorean theorem. What the fuck am I thinking? So that's 2 times 2 times 2. So the square root of 2 times 2 times 2. The even ones are pretty easy because it has a pattern, but odds, I don't know. I haven't actually tried this, so in this video, we're going to spend another fucking 30 minutes figuring out how to do this shit. Let me take a sip for a second. Oh my gosh, my fucking bones, I can feel it cracking. Not the chair, by the way. I know the sounds are from a chair, but you know, I could feel the crack of my own legs because I've been standing here for like 29 minutes. I'm at 30 minutes actually total. So how do we solve this? Okay, 2 cubed. Okay, that's pretty basic. 2 times 2, 4. And 4 times 2, it's 8. Okay, 8. Square root of 8. What's square root of 8? So what is the square root of 8? Okay, so let's break it down a bit. Okay, fuck. So the square root of 2 cubed. So 2 times 2 times 2, that's 8, right? 2 times 2 times 2 times 8. Now we're asked to take the square root of 8. How do we do that? We can express this using a Pythagorean theorem method. Okay, let's see. 2 squared plus 2 squared, something like that. It's just an example. This is not the right answer. I know. So it is 2 squared. Okay, 4 plus 4 is 8. Oh, it is. It is the correct answer. Oh my gosh, 4 plus 4, 8. Yeah. So 2 squared plus 2 squared. A Pythagorean theorem method. 8. So let's have an example over here. So, for example, we're asked to get the hypotenuse if A and B is 12 squared plus 12 and 12 as well, equally 12. So 12 squared plus 12 squared is equals to 12 square root of 2. So anything, if A and B is equal, it always adds up with square root of 2. 2 squared plus 2 squared. As usual, if A and B is equal, then therefore it can be A or B multiplied by the square root of 2 because they're equal. Because A equals to B is equal. Okay, now we know that. Okay, now we know that we have solved the problem. Could this be it? Let's find out. Okay. 2 squared plus 2 squared is equals to the square root of 8, which is, we can then say that since this is A, this is B, and they're equal, so 2 square root of 2. Because these type of equations always have is always multiplied by the square root of 2. It's constant. In these types of equations, square root of 2 is constant. Now you see the pattern. Now we have found the pattern because I just found this just now. I just realized this just now. So let's apply it to other odd equations. Okay, let's do it. Okay. Let's apply it to some odds. Okay, let's do it. Square root of 3 raised to the power of 5. Okay. 3 square root. Okay, the square root of 3 raised to the power of 5 Okay, now things gets different over here. Okay, so square root of 3 raised to the power of 5. So that's basically 3 times 3 times 3 times 3 times 3. Okay. So it doesn't actually follow a pattern over here. It's just simply so these. Okay, now we know that these types of in the Pythagorean method, if this is like a special case, of course. So okay, so 3 raised to the power of 5. Okay, 3 raised to the power of 5. So let's move on to this. So how do we actually get this? So I'm pretty sure this does not result to a number multiplying by 2, square root of 2. This is instead square root of 3. So let's find out why. Let's find out why. Okay, so 5. 5. Okay, so 3 times 3 times 3 times 3 times 3, 9. 27. 7, 14. 21. Okay, not bad game. 20. Oh shit. Fuck! Keep forgetting my math. 21. 36. 8. 81. 81. We got 81. 81. 3, 8, 16, 24. 2, 4, 3. So it's 2, 4, 3. Okay. 2, 4, 3. So 2, 4, 3. 2, 4, 3, yes? So we got the square roots of 2, 4, 3. Let's verify if it's true. That's right, 2, 4, 3. Okay. 2, 4, 3. Square root of 2, 4, 3. Now let me just test some facts over here. Okay, things got a bit difficult. Odds are so hard to control. But, wait. So, 3 squared. No. Yeah. 3 squared. 3 times 3, that's 9. So squared. I think I already know the pattern. I swear. So if 2 cubes, okay. So if 15 raised to the power of 3, 15 cubed, that's 50. No. Okay, it's even more complicated. Oh, fuck. Because it doesn't follow any pattern. This is odds. Okay, how do we do this? 3 squared. So we have 9. So 9 squared, 3. We know that. Doesn't follow specific. Oof, okay. So there's a pattern for square root of a raised to the power of 5. I just noticed it just now. So in order to get a raised to the power of 5 is equals to a squared multiplied by the square root of a itself. It's always that. Trust me. Because for example, 13 raised to the power of 5 is just simply 169 square roots of 13. It works. It works. Okay, let me show you. Right? 13 raised to the power of 5. Square root of 13 raised to the power of 5. This value, yes? I don't know if you guys can see it. Let me just go ahead and peek into the camera for you guys to see properly. Yes, we got that. 609. Yes? Yes. Pretty sure you guys know. So, okay, next up we got 13 raised to the power of 5. You know that. Okay, up next we got 169 square root of 13. Let's find out. Got this. See? It works all the time. Okay, let's have another example. Over here. Let's find an odd. Okay, 7 cubed is equals to... Okay, what's 7 times 7? What's 7 cubed? What's 7 squared? I forgot. 49. Okay. 49 square roots of 7. So let's find out. Square root of 7 cubed. Which of course simplifies to 7. Which we can also say 7. Since this is, not much of a large number. But anyways. Okay, we got that. So let's compare it with ours. Okay, it's significantly big. That doesn't apply to numbers that are not tens. Okay, so we're wrong on this one. Okay, we're wrong on this one. But when it comes to numbers like these, something like these, of course. Oh, why is odds so fucking hard? Because I don't know, it can be simplified. No, I can't see. Why? Why does odd exponents have to do with this? I think it's your turn, chat. I'm pretty sure there are some people in the comments that are definitely better than me and know a trick that can solve this way much faster, like the fastest way. I just now provided the ones when the exponents are even. So now, it's your turn to discover, so it doesn't sound very sinister. It's your turn to discover it. Find a trick for the odd numbers in exponents. Because apparently my brain cannot process it enough. But I hope you guys enjoyed and learned a lot by the other lesson, which is the trick when the exponents are even. But for the odds, they don't follow a specific pattern. I'm pretty sure. Some in specific scenarios they do follow a scenario, a pattern, but it's not constant. They change every time. So I might need to do a further research on this. So be updated on the next video. So I'm sorry if it's really long. So yeah. What the fuck? Jesus, the fucking door. The door on to the clothes room, it just fucking fell. Oh my goodness, I got scared. Why does Gravity have to be a horror movie? Jesus. Okay. Whew. Thank you for watching. Thank you for watching. Thank you.